Hey guys, today we are going to talk about the problem 669, trim a BST. Okay, so the problem statement is like this. Imagine you have a BST, something like so, 1 0 2. This is your BST, and you have two boundaries, low and high. So in the problem they gave low as 1 and 2. Then you need to return a new BST whose all values stay in these bounds, meaning the result should be something like so. Different pen here. Yeah, result should be something like so. Let's take a different example. What if I have like a new lesson 9, 5, 14, I don't know, 3, 7, 11, 20. Okay, this is my given BST, and low is low and high. Let's say low is 7 and high is 14. Let's say, how does this convert into, right? Now the values that are currently eligible for this new BST are 7, 9, 11 and 14, right? That means these values are the only ones that we should get in the result set, right? So we could form the tree something like so: 9, 7, something like that. I don't know if this is an accurate BST. Probably it is, but I think it should come something like that, right? So here is the first logic, right? The first logic here is, see, at every stage you can solve this problem recursively, right? At every stage you are going to check what value you have here, right? So this is the given BST. That means you have access to the root, so that means 9. The current value of the root is 9. Is this 9 inside this boundary or not, is the question that we are asking, right? It is. So you move on to left, let's say, right? Is this number within these boundaries? No, right? So that means everything to the left of it does not satisfy, because this 5 is less than the boundary, right? This 5 is less than the 7, so you can discard 5 and 3, right? Then you will have something like, you have something so far, right? This is step number 1. Then in step number 2, you came to 7, you are fine. You go all the way back, come to 14, you are fine. You go left, 11, you are fine. Come to 20. Then the moment you are in 20, right, because it does not fall in the boundaries again, right, you are going to discard the entire right tree from here, right? So it could have something like, I don't know, 30, whatever, right? So you are going to discard this entire thing out, right? So this eventually will result to this guy, right? Now, so what are we doing? Let's write that down in simple English words. What are we doing, right? We look at root value. Okay, then check if it is in boundaries. Okay, now the check is if root if root dot val is less than low. If root dot val is less than low, discard left branch. Remember, this is a BST, right? This is a BST, right? Now, if root dot val greater than high, you discard right branch, right? Now, if you write code for this, it will be something like so, let's say trim BST tree node root int low int high. This is the method signature. Now what you would do is, if root dot val less than low, you just say return trim BST. You got to discard the left branch, so you have to work with right branch. So you are working with right branch, you return root dot right low high. Similarly, if root dot val greater than high, you are discarding right branch, so you are working with the left branch. You say trim BST root dot left low high. Okay, so far you're okay, right? So let's say this is returning tree node. Yeah, so far you're good. Now what happens, so this is fine, right? This is fine, but here in our example, the 9 does not fall into this condition or this condition. Only when it moves left, it does follow, right? So obviously you need your left traversal. Excuse me, but I'm sorry, I have a slight cold. But so now what will be your left branch, right? So that means the root value is within the boundaries. Now what should I do with the left branch? So the root dot left will be, you are calling the same function again, you are calling trim BST, right? Immediately you will invoke this on root dot left low high. Correct? Because you want to go to your left and ask these two questions again. Let me point with blue pen. You want to ask these two questions again and say, well, now I'm left, do I still satisfy your condition or not, right? Then in root dot right, you are asking the same question, just traversing to right, and eventually you're returning root. That's it. Yeah, this is your entire code. Yeah. Yeah, if any questions, just hit me up. Thanks.